Welcome, welcome, welcome. It is Tuesday, February the 3rd, 9 p.m. here in the DMV. I'm
And
Sam
six,
Jacinto.
and 6 p.m. here in Los Angeles. I'm Jack Armstrong. Today we have a very special guest joining us. We have Peter Voss. Thank you so much for joining us.
Yeah, thanks for having me.
Peter Voss is an AI pioneer and serial entrepreneur who is famously credited with coining the term artificial general intelligence, or AGI, back in 2001. Currently, as the CEO of Aigo.ai, he is architecting the third wave of AI, developing neuro-symbolic systems that move beyond static limitations of today's LLMs to enable true reasoning, disambiguation, and long-term memory. Thank you for joining us. Welcome to the show.
Welcome.
Yes, well, thanks for having me.
So I think we should start by just simply going over what AGI means, right? And why that's important to kind of define.
It seems simple, right? But
yeah, absolutely. And unfortunately, the term has been distorted quite a bit. When actually three of us coined it in 2001, 2002, around about that time. And the idea was to get back to the original dream of AI. The term AI was coined some 70 years ago, and the original idea was to build thinking machines that can think, learn, and reason and operate, like we humans do. And they actually thought they could crack this in a few years, 70 years ago. And of course, it turned out to be a much, much, much harder problem. So what happened to the field of AI is it became the field of narrow AI, where you take one particular problem that requires human level intelligence, and you then engineer it using human intelligence to solve this problem using computers. So it's not that the computer figures it out by itself, it's that the engineers do. This is really the field of AI, even today, that we have. So good examples there would be expert systems, in the 80s and 90s. And then we had IBM's Deep Blue, the world chess champion. But those are narrow AI. They're human level, in fact, superhuman level in many cases. But they're not general, and the intelligence is not really in the system. So a couple of us around about 2001 got together and decided the time was ripe to get back to that original dream of having machines that can think and learn and reason like humans. And so we decided to write a book on this and to come up with a book title and to kind of differentiate our work. We decided on artificial general intelligence, basically a system that has the core intelligence to learn how to play a good game of chess or to do container optimization or to become customer support or whatever, that it can learn autonomously by itself with no more information and no more time than a human would take. And that is the field of AGI. Now, unfortunately, in the frenzy of trying to get funding for large language models, people have now abused this term. And Sam Altman saying, I think a year ago or so, he said, oh, we'll have AGI soon, but it's not going to be a big deal. If we have AGI, it's a big deal, and then anyway, he's of course changed his mind, then at another time we'll say, oh, we're no longer pursuing AGI, we're now pursuing super intelligence, and that's just a sleight of hand, and it's actually complete BS, because super intelligence, basically it's a bait and switch thing. They're saying we'll have systems that have super intelligence, that are more intelligent than humans in specific domains, but that's going back to narrow AI. I mean, we've had super intelligence in calculators for decades, we have super intelligence in playing Go. So and the reason for that is because the large companies, and this is a strong statement I'm making, but I can back it up, I believe, the large companies have no idea of how to get to AGI. They are fundamentally on the wrong path. They are trying to brute force it. They basically, that's the hammer they've got, is massive amounts of data, massive amounts of compute, and now massive amount of data center build out. that's the only way they can think about solving the problem. That's the hammer they've got, so they try to make it look like a nail. But that's not what human intelligence is about. Human intelligence is about being able to adapt to changing circumstances autonomously without getting a new data set, without having to have a new training run. As a human, we can learn language and reasoning with a few million words. We don't need trillions of words. And these current models are trained on tens of trillions of tokens. Tens of trillions. That's 1 million times more than a human needs to learn language and reasoning. It's clearly, it doesn't pass the smell test, basically. And our brain operates on 20 watts, not 20 gigawatts. It doesn't need a power station up in orbit or some, whatever they're talking about.
No reactor. What?
Yeah. So it's they basically have locked into this brute force technology that has achieved amazing things. I don't want to take away from what these large language models, Gen AI, can do, but it's not AGI, and it's not on the path to AGI.
Well, one thing that sticks out to me is how you emphasize the plasticity of the brain in terms of adapting and iterating on a problem. And I think that seems like an architectural limitation of an LLM as they exist. And there are brick walls when it comes to, I was reading up, on the kind of like the security triad and cybersecurity and confidentiality, integrity, availability. In AI, it's, compute, data, and algorithms. Those are kind of your three ingredients. And at a certain point, there's only so much compute that we can reasonably acquire and place in one location. And I think we are kind of approaching that practical limit in some ways. A $500 billion data center or whatnot, all this money flying around. And at least in recent times, I mean, even in the past year, I think there's just been an explosion of, we're kind of seeing the absolute maximum of how much, we can really put in one spot. But after that, there isn't, the scaling is a big problem that comes out of that. We can't keep, there's a limited number of chips we can make at the end of the day.
Right. Well, and the bigger point is it's A, unnecessary, and B, you cannot brute force it. The current architecture that everybody is using relies on backpropagation. And what basically what that means, quite simply, is to teach the system, you need to have all of the training data available up front. So you have your 30 trillion tokens, 10,000 words or whatever, 10 trillion words that you've got from the internet, from books, from wherever you could find it, good, bad, and ugly. And you have no idea what's good, what's bad, and ugly. So you have these 30 trillion tokens that you then number crunch for months on end, billions of dollars or hundreds of millions or billions of dollars worth of number crunching, and you then end up with a frozen model. The model is frozen. It cannot change. The weights cannot be changed other than through, at the edges, a little bit of fine tuning and so on. But basically, the system cannot adapt to new knowledge. And that is a fundamental flaw. And that's not how our brain works, how our mind works. It's not that, evolution builds. I mean, for some animals, that's closer to what they do. They cannot adapt. They're in a niche, and if the environment changes, they die. But in the human adaptability, in fact, my first AI company, I called it Adaptive AI Inc., A2I2, to focus exactly on that is the key to human intelligence, is the ability to adapt. Now there's more to it, but that's key to it. So with large language models, Gen AI, you are stuck, in transformers, you are stuck with backpropagation. You can't get away from that. So you really need to throw that out. But clearly, these large companies aren't willing to just throw out.
It's a sunk cost fallacy. Yeah,
and it's even
trillions of dollars.
the people in charge are so determined that they've gone so far down that road they really just can't turn around, and say we're on the wrong path, we've got to scrap everything and start from scratch, and they don't actually understand what intelligence requires. And I can give you two examples there. Demis Hassabis, brilliant guy and fantastic what he's achieved, with AlphaGo and AlphaFold, a great achievement. But he in an interview recently said, we don't understand intelligence. We have to build AGI in order to understand intelligence. Now, to me, that is upside down. How are you going to build something that you don't understand? Then you just hope you're going to stumble on it somehow, and that's going to tell you what intelligence is. Whereas I think the correct approach is that you first understand what makes human intelligence so powerful and so special, and then you build a system that incorporates these requirements. I had a discussion with Elon Musk as well, and when I told him that we are building something based on first principles of intelligence, he was quite dismissive about that. He says, nobody knows what intelligence is. Intelligence is what intelligence does. And that, to me, is fortune cookie philosophy, That's not epistemology. That's not cognitive psychology. That's not... We do understand a lot about intelligence. And I must say, I have a great admiration for Elon Musk for, all the things he's achieved in his companies. I drive a Tesla. I think it's amazing. And I follow the rockets. But as far as understanding what is required to get to AGI, to have true AI intelligence, he simply doesn't have the right model to even think about what intelligence is. Well, as I say, he's dismissive. And I think it's true. That's pretty much with all of the big labs. They are not starting from first principles and understanding intelligence, because then they would come to the conclusion, you've got to throw out backpropagation. Gone. Which means pretty much all of the technology, all of the papers that are being written, all of the expertise there, all of the billion dollar high have are going to be useless, because their training, their understanding, their expertise is in statistical systems, in backpropagation, transformers, and so on.
So I have a question. When you keep bringing up backpropagation, is this I think you, in your paper of the architecture of AGI and knowledge integration, is it, when you say backpropagation, is this the problem with it because of data scaling, or what is the actual problem?
The problem with backpropagation is that whatever you want to teach the system, you have to have all of that knowledge available up front. And then you number crunch it, as I say, for weeks on end to converge to that model that they're building. They cannot learn incrementally. So they cannot adapt to changing circumstances. And there are basically a number of problems with backpropagation. And our brain doesn't use backpropagation, I mean, as a kind of reference point, The problem is incredibly expensive, because you have to number crunch 30 trillion pieces of information, whereas we and a child, and we as humans, we learn essentially one sentence at a time, and that requires a lot less computational power. As we're having this conversation right now, you may say something, I listen to it, and do I understand what you're saying? Does it contradict something? Is it a question? Do I need to elaborate? Do I need to ask a follow-up question, clarification? So we process proactively information we're getting, and then if we update our model in real time, incrementally. So something you say will then, depending on how profound it is in terms of existing knowledge, there may be a lot of thinking going on. Like before the last election, we didn't know who was going to win, and then somebody says just two words, Trump won. Now there's a whole lot of updating of your priors and your assumptions that basically happened because of those two words. And large language models simply cannot do that at all. In fact, if you've tested them, weeks later, they still didn't know who the president was if they didn't have access to the internet and, to basically do a search. but their model wasn't updated and can't be updated. You can't have real intelligence that cannot adapt and change and learn on the fly with limited data. And transformers, and in fact, all of the deep learning, machine learning approaches totally rely on backpropagation. They cannot function without that. So that, and that's why it's a dead end. In fact, Jan LeCun, and I love quoting him, he says, large language model are an off-ramp to AGI, a distraction, a dead end. He puts it very forcefully. So, he now has his own company pursuing an approach where he wants to build models that interact with the world and build world models. I have some problems with that approach as well, but certainly he agrees that, large language models are an off-ramp, a dead end.
I thought the point about for some people intelligence being output oriented as to it's almost what it can accomplish versus understanding what it truly means from a philosophical perspective. And I sometimes zoom out and like to think, in some ways from psychology, we still don't have a fundamental understanding of how we work as a species sometimes, whether it be mapping the brain or understanding what every part does. So it's interesting to sort of see those same concepts applied to machines when in some ways psychology is still a very fluid field in of itself. And what it means to learn and be intelligent or even be human is still, that definition is changing. So I think it's interesting that some people say, well, what can it do and what can it accomplish? It seems
right. And I've written quite a bit about the problems of benchmarking and benchmaxing.
Yes.
Basically fine-tuning systems to specifically be good at beating benchmarks. And that again is the problem of narrow AI. But I can give you some very, very simple examples of, never mind if a system can ace an IQ test or law test or whatever. Current large language models are totally incapable of taking a large language model and putting it into a very simple, for us human, very simple position of customer support. It's an area, our commercial business, we're actually in customer support. If you take a large language model and put it into a new company for customer support, they need tons of specific training data. You go through this training run then and so on, and put in all sorts of guardrails, and it's hundreds of thousands, if not millions of dollars worth of work and weeks and months of work. That's not at all like human intelligence. If any of the three of us go into a call center, we read the manuals, ask a few questions, listen to some calls, and maybe a training course or something like that, and then we start taking calls. And we know when we don't know something and have to ask for a supervisor, and we learn on the job. And if something changes, new products, business rules, there's a snowstorm, whatever the case may be, or you have a particular customer that you have to handle with kid gloves or whatever, we learn that on the fly. And it's not just a rule that is put in, we learn the implications of that. And for that, you have to update the model. Large language models cannot do that and will never be able to do that. You can't just do that in the input buffer or in an external RAG database. Not doable, not possible. So they fall horribly short on that. So when you say you want to test what the system can do, it cannot just be a static test where you ignore how much training you've put in. You have to evaluate how the system learned to be able to do what it can do, what you're testing for. Did it have roughly the same amount of training data as a human would need for that? It's like even playing chess. In fact, one of the things we're doing right now with our current system, we're teaching it chess the way a human would learn chess, not with millions of games that are played that it can statistically extract and then optimize to it. And what we're actually doing is we're also changing some of the rules and the way the board looks and so on. And the large language models, with all the trillions that, $1 trillion have been put into that, fail on that. If you say, look, we're going to play a game with different rules, and here are the rules, they can't cope with that, whereas a human clearly can, can say, hey, we're going to be doing this differently now. So adaptive real-time learning with limited data and autonomously monitored, that you don't have a human in the loop preparing the data, monitoring, tweaking the knobs until you get it right. No, it has to be able to learn and adapt in the real world. And large language models are just the wrong path.
How far in development are these alternative learning architectures? Like I know the big companies are focusing on the wrong architectures, but is this progressing at like how rapidly are these changes towards AGI?
Yeah, so at a snail's pace. And the success of large language models, I mean, they've been tremendously successful relative to what we had 5 years ago, has really sucked all of the oxygen out of the air. You want to get a paper published, you want to do a PhD, you can't even find a sponsor for cognitive AI, which is the alternative. And I can talk more about that. Neuro-symbolic approaches, cognitive approaches. You basically can't get a sponsor for it. You can't get funding for it. You want to have a startup get funded for it. You can't. You want to earn the big bucks. You don't. So it really is a problem. And our company is currently only 12 people. So we're working at it, progressing and moving up the IQ chain in our system. But 12 people is not a lot. Intel had a project on cognitive AI that just got shut down because they're not doing so well. There is another person who was heavily involved with IBM's Jeopardy program, and he had similar ideas. His company is just shut down a few months ago. There really are, our little small effort of 12 people is probably, to my own knowledge, it is the biggest, the most advanced project on cognitive AI. It's really quite pathetic. As I say, the oxygen's been sucked out of the air. So now the tide is turning, and over the last 6 months, pretty much all the big labs have had interviews and spoken and written about the need for ongoing learning. In fact, I've just finished writing an article, which I'm going to publish shortly, on what ongoing lifelong learning actually means. Now, they're still missing the boat, but they're realizing that that's the Achilles heel of the system, that they cannot adapt. They cannot change. So you build the system to do customer support or to do accounting or whatever. And then, first of all, it costs an arm and a leg to build the system, get the training data, tweak it, test it, and so on. And then every few months, you have to go back and retrain the system and redo it and tweak it and so on. And then there's still, that's why there's been such poor adoption by enterprise. It's only 5% of the projects go from a prototype or demo into production because of these difficulties. So it is that is a real problem.
I guess I'm curious. I mean, do you have any theories for why capital isn't following? Is it just a matter of since everybody is pursuing this method with shortcomings, it's sort of anybody who quits could is it just a matter of a charade where it's like we just need to convince enough people that we can perform something that's useful, and then that's enough?
Yeah, but believe me, we have spent a lot of time thinking about that, because we are very hard at looking for an aligned investor for our Series A to scale up our team, and the amount of money we're looking for is ridiculous. It's a rounding error. We're looking for 25 million, whereas you have LLM companies that get $1 billion or $2 billion of seed capital, with no product, no real roadmap, just, hey, these are smart people, let's give them some money and see what they can come up with. So we certainly thought a lot about that, and it's a combination of various things. One of them is most investors are followers, very, very few leaders, so it's basically jumping on the bandwagon. And that system kind of reinforces itself. And we are now, many years into the deep learning, machine learning thing, where, everybody has convinced themselves that's what it is. And of course, they have to double down on that commitment, on that money, on the money they've invested. And the problem is talking to these people. I mean, it's hard to even get to them, because they're gatekeepers, look at what we're doing and say, cognitive AI? I don't understand that. I'm not going to embarrass myself and give this to my boss, but even when we get to these people, they're not of the mindset that they are open to learning stuff. They're of the mindset of shooting down things. They get hundreds of proposals and sort of, okay, does this make sense or doesn't make sense? They would actually literally have to unlearn stuff that they think they know about AI. And that's very hard. These individuals, running VC companies, are not really in the kind of frame of mind to say, well, hey, we may be wrong on this, and I have to unlearn to even pay attention to it. And and then the difficulties, like I said, I will start talking about cognitive AI. I'll start talking about epistemology, the importance of concept formation, and their eyes glaze over. It's just not stuff they're familiar with, and they just don't feel that they can even have that conversation about what intelligence is. It's sort of like, nobody understands intelligence, nobody understands consciousness. And my reply, hopefully more politely than that, is, well, speak for yourself. There are people who do have a pretty good understanding of what is important in human intelligence. We may not understand everything about it, but we understand enough of, why current AI cannot give us a kind of intelligence we need and what is required. We need fundamentally a system that can learn autonomously in real time with limited data, and a number of requirements like that. And you basically need a fundamentally different architecture. You can't have backpropagation. You can't have transformers.
And you bring up an excellent point, as far as the sunk cost, and sort of, you have a vested interest at a certain point. You need to believe in the success of what you've, put your effort and money toward, in a way where it's like you're doubling and tripling and quadrupling down. That they don't, they almost
and they money to be made, of course. I'm not saying there isn't money to be made. And yes, of course, if you're deep into it, and I mean, some of these valuations are clearly way over their heads.
A little bit of mania.
And then as an investor, you scramble, hey, can we offload this pig? Can we list it? Can we get a listing and, take our profits? I mean, we saw a spate of listings over the last few years with reverse mergers. I don't think any of them succeeded, but the investors got their money out.
So from an efficiency standpoint, obviously the big AI players don't seem to be, with all the back propagation, right, that they're doing. Is it more efficient, I guess, to kind of two questions. Does it worry you, the track that OpenAI and Anthropic are on, in terms of, training this massive amount of data to kind of get to a kind of a dead end result? from an environmental standpoint, an energy use standpoint. And then these models that you speak of, these alternative AGI autonomous learning systems, I'm assuming that they're more efficient than the current AI systems.
Oh yeah, absolutely. I mean, look, there's nothing I can do about the build out of data centers and what is being done. I mean, that has to just run its course, and some of it will be useful. And whatever. As I said, it's not something I can really worry about, and it's going to take quite a lot longer because you have permitting, you have shortages of chips and equipment that's going to take time to do. Some of these financial commitments, I'm sure, aren't going to basically materialize. It's one thing announcing $100 billion investment in a company on paper, and actually writing the checks. So, but anyway, that's not really my concern. To your question, is our approach much more efficient? Oh, absolutely, massively more. And and this is the reason why we're not looking for hundreds of millions or billions of dollars. We don't need huge data centers. We train our systems on off-the-shelf computers. So we are much closer to the 20 watts that our brain uses than the 20 gigawatts that large language models need. So it's way more efficient. They literally can run on a laptop, on a current laptop, and that has many advantages as well, because it means you can ultimately have your own what we call a personal assistant. So that you own it, you control it, not some mega corporation, and it serves your purpose, not their purpose. So that you're not always a slave to their engagement farming, and trying to hook you on their system. So that is one of the advantages. Another huge advantage is because our system only needs millions of words for training and not trillions, you can concentrate on the quality of what you're teaching it, not the quantity. So you can make sure that it's closer to reliable information, good information, and the kind of knowledge that you want to give it. So yeah, there are huge advantages in efficiency and quality. You don't have hallucinations, and you have a much more reliable system.
One thing I wanted to bring up, and I found this searching around, and I thought it was curious. Back in January of 2020, you wrote about rational ethics, and given the wake of perhaps, I mean, very historic altering event which has happened since then with our friend the pandemic. I'm just curious if that's impacted any sort of, I mean, in some ways you would say the tenets of ethics and morality stay the same regardless of external happenings. But I'm just curious, revisiting it. I guess January 21st. Yeah, I mean, just over 6 years later. I'm curious if anything you've seen or since then has changed your thoughts or opinions on it.
No, in fact, it has reinforced them. On Substack, I actually have some recent articles about ethics and related things. And I still firmly believe that additional better intelligence will help us to become better people. That a lot of things that we do, a lot of decisions that we make because of human failings or subject to human failings, that we tend to react emotionally. And, I use 9/11 as an example there. Something terrible like that happens. We just want to hit out. We want to get back at somebody, anybody, somebody, Yeah. So Iraq, okay, yes, let's go. We're not very good at doing research and really getting to the bottom of things because it's hard work, to try and get to the bottom of things. So weapons of mass destruction, check, yes, we can justify going to it. And then we're also not good at thinking rationally about things, logically about things. rationality is an evolutionary afterthought for us. We only have this sort of
Yeah.
thin veneer of rationality that we managed to do. So that is, even saying, okay, weapons of mass destruction, we've got to get back at them. But then, is invading Iraq actually going to give us the, if you think forward, even the best outcome? Is that the outcome that we want? Or is there a better alternative? So there are many failings, human failings, that can be minimized by better intelligence. And having this personal assistant in a way is like an angel on our shoulder that can say, well, maybe you want to just think about this for a bit before you break up your relationship with, or make this investment or whatever, and let me do some research for you about this, and let's think this through, or the consequences. Is there a better alternative? So I think I'm convinced that, and that is another way of talking about morality or ethics, is doing things that we regret, or doing fewer things that we regret. So I'm absolutely convinced that having the right kind of personal assistant will help us to become better people and help us, deal with difficulties and crises and so on.
I like that way of framing it. It's that rational voice on your shoulder. Because we already have the the id, or the the basic hit back. We already have that pre-programmed from eons of iteration.
Right.
That's an interesting way of framing it. Yeah.
I have a question for you. You speak a lot about the integrated neuro-symbolic architectures as like being a core part, and then I know there's the integrated into the 3-layer knowledge graphs, but can you walk us through how, let's say, like a fact from a conversation would be become available for reasoning without the need to retrain the entire model? So you could say, does that make sense?
Yeah, absolutely. Very good question. So let me backtrack a little bit and talk a little bit about the architecture and why we're doing what we're doing there. A few years ago, DARPA came out with a model of describing different AI approaches that they call the 3 waves of AI. And the first wave was what's now called good old-fashioned AI, literally called that, and which is really logic-based systems, and expert systems were an example of that. IBM's chess champion was an example of that. So that's the first wave. Now, the second wave hit us like a tsunami, and that is statistical, big data, deep learning, machine learning, large language models. That's the second wave. So roughly speaking, the first one is logical, symbolic, logical, and the second one is neural network based, very roughly speaking. Now, the third wave is kind of, it's not, I just had my computer go blank for a while.
Oh no, yeah, you're still there.
It knows what we're talking about.
Yeah. Yes, it's taking over. So the third wave is not so much what the architecture is. It's basically focusing on the ability to be adaptive. The kind of things we've been talking about. But it's important to realize that you can't just take first wave technology, the sort of symbolic reasoning engine, and take a neural network and just sort of join them together. And this is actually what some people are now trying to do, is to have logic engines that sit on top of large language models and try to correct them. This kind of another layer of guardrails that some people are trying to put around that. But that's not the answer. And the reason why that's not the answer is you end up with the worst features of both systems, or the limitations of both systems. You end up with the brittleness of the symbolic system, and the hallucination and the lack of learning ability, real-time learning ability of large language models. So you can't just take those technologies and glue them together in some way. You have to have a system where the knowledge representation is identical for both your sort of pattern matching, which would be more like the neural network stuff, and your logic reasoning, which is language and, symbolic reasoning and language mathematics and so on. They have to be totally integrated as they are in our brains, in our minds. In fact, another way of looking at how this works is what Daniel Kahneman calls system 1 and system 2 thinking. So roughly speaking, system 1 thinking is our automatic subconscious thought process that happens, which is active most of the time. If we're speaking like we're speaking now, most of it is kind of automatic, it just happens without effort. But then we might stop and think, oh, okay, here's my audience. What do they know? Maybe I should elaborate on that. And that is monitored by your system 2 or metacognition, where your metacognition monitors the automatic stuff that's happening. It can then redirect that. And logical thinking, basically, and thinking about thinking happens at this other level. But in our brains, they are, of course, totally integrated, and we can seamlessly change and do between these two modes of operation. And this is why we call our approach INSA, integrated neuro-symbolic architecture. So we take the requirements of pattern matching, the sort of the neural network type stuff, the fuzzy matching and so on, and the requirements of language and reasoning and mathematics and so on are all represented in one uniform knowledge representation. And none of that relies on backpropagation. So to answer your question about how a system learns is, if we input something, it'll evaluate the input and can I pass this? Can I make sense of it? If not, it might come back and say, can you rephrase that or something, And then it'll compare it to knowledge it already has. Is there a contradiction? If there is a contradiction, it might look for additional context and say, I'll give you a concrete example. When DeepMind was sold to Google, there were a lot of articles came out, were sold for 400 million, other articles 600 million. So that's a contradiction. You dig a little bit deeper of where did I hear that? And you find out, well, the one was UK pounds and the other one is dollars at the time. So, that proactive process that's happening, and then the result of that simply updates the knowledge graph that we have. So that all happens in real time as the system ingests new information. Does that answer your question?
Yeah, sort of.
Sort of.
Yeah, it's interesting to think of it because I think we're programmed we just hear so much about OpenAI's approach and Anthropic's approach that you're right. We're kind of brainwashed into thinking we need the transformers, we need all the training data, and it's interesting to hear that's not really necessarily the path forward. I do think it's interesting, obviously, looking towards the future. Obviously, it's going to be radical at how it enhances our society. I am curious, based on where things are at now and whatever company gets there first, I'm not saying it's necessarily a race, but what do you think is going to be the most profound societal transformation from AGI?
It'll really change everything.
No, I know, yeah. But do you think it's more likely to cure a cancer before it does your dishes?
Right. So I tend to put it into three buckets, and one can divide it up in different ways, but I tend to put it into three buckets. The one is scientific, is basically research related. Is, imagine having one AGI that trains itself to be a PhD level cancer researcher. And I say trains itself because that's, again, important. It's not that you're giving it, that you're force feeding it all of this predetermined data and number crunching it. It literally would hit the books like a human and integrate the knowledge as it acquires it. So you have one PhD level cancer researcher now at sort of a basic understanding, you can now make 1 million copies of that. And you have 1 million PhD level cancer researchers pursuing different avenues, pursuing different ways, communicating with each other much more effectively than humans, without egos getting in the way. Also working 24/7 at probably a much faster pace than a human would. The progress we'll make in science will be amazing. And, this is true for whether it's now energy and whether it's quantum computers or nanotechnology, having little microbots finally that can go in our bodies, material science, food, energy, pollution, you name it. Each of those areas, the bottleneck is intelligence. We don't have enough intelligence to apply to these things. And AGI will, just massively improve the amount of intelligence we can bring to bear on these problems and solve many of them, of the diseases and energy and so on. So that's kind of the one bucket. The second bucket is drastically reducing the cost of goods and services through automation. And robotics will follow very quickly behind AGI. The initial AGI will be just desktop bound. But once you have this brain that works on a desktop, then you can put it into a robot and it can basically control a robot. In fact, there's an insight I got today while I was writing an article that hadn't occurred to me. It now seems like super obvious, is all the specialized car companies, self-driving companies, and we've just, I think yesterday, had another announcement of $500 million investment through Uber. They're going to become completely obsolete, because once you have an AGI that has visual ability of a human or better, and even very limited dexterity, it'll be able to learn to drive any car within hours of training like a human. You simply will not need dedicated self-driving software. So so the second bucket is basically dramatically bringing down the cost of goods and services and all that entails, radical abundance. And the third bucket is the one we've already spoken about, is this personal assistant. And to me, I'm actually even most excited about that, is how it can boost human flourishing. And the vision that we have and the kind of investment partner we're looking for is, it's important for us that they share our vision. We don't want to have a personal assistant that is designed to get you addicted to it or sell you stuff, or like OpenAI is now adding ads.
Yeah.
That's terrible. It's terrible. It's all, we need to get away from you being the product, a personal assistant. And we need partners that share our vision. We need to boost human flourishing, which means you need to boost human agency, whereas current AI is on the path of reducing human agency. It basically doesn't encourage you to think or do things. It just wants you to react and, get hooked. And that is a very firm commitment we as a company have, and I, specifically have, is to create a personal assistant that is specifically there to optimize human flourishing, to optimize human agency. And, that is, I think, will be the most profound change. But of course, the other two I mentioned are huge, and yeah.
Well, I know we're running out of time, but I was hoping you could touch on, so traditional LLMs, hallucinations have been like a cause of concern, and but going back to the research argument for a second, like I find it interesting with AGI. How will it be able to distinguish, something that's not necessarily factually accurate based on true reality? Like, I mean, we already see, image generators that are basically extremely photorealistic, and to our eyes, you can't trust if it's real anymore. Like, it is so hard to distinguish. So from that perspective, with this type of AGI, how will it be able to distinguish what it created versus what is actually like real or true?
Yeah. So those kind of questions of, the limitations of AGI. So my first response is always, well, it's going to be at least as good as you and I are at this. So I'm not saying it can't get fooled, but in fact, it's not going to get fooled as easily because it has more patience and it has more tools, for example, to analyze pixel or variations or do whatever, it can do more research. What is the source? I mean, how often when we see something that we say, oh, I'm not sure about that, and, sometimes we'll do, okay, I think it's probably true, and we'll that'll be what's filed away. But an AGI isn't going to have that limitation. It can drill down and say, okay, let me do the search and see what is the source. Where did this come from? So it'll be much better at what I refer to as objectivity. Objectivity has two components to it. The one is, does it concord with reality? Yeah. And basically you try and find the original source of things, and that will give you the best chance of determining that. It's not, it's not foolproof, of course. So that's one aspect of objectivity, is does it concord with reality? And the second one is, does it contradict anything that I know? Because there aren't contradictions in reality. So you try to minimize contradictions that you have. Like the example I gave, was it 400 million, 600 million? That could be resolved. You can't always resolve them, but usually if it's important enough, you can basically dig deeper into the context, into the sources, think about it, or proactively ask questions, do inquiries, and get to the bottom of it. So it'll be much better than us at being objective, and that's as much as we can hope for.
I know we're a little over time, but if I can squeeze something in, something I was curious about with neuro-symbolic as an architecture. In terms of compute, it's obviously very efficient. In terms of storage and how memories are stored, and what limitations exist in the storage realm. I mean, the brain itself, I guess, how memories are stored is still, a very fluid field in of itself, but I'm sure it discards things that it doesn't find particularly useful. Or so is storage a limitation, or does it function in the same way where the most relevant information is kept in the forefront or close to working memory, and perhaps a childhood memory is discarded because it simply can't? I mean, there's in theory, I guess, no limit to the storage size, but I'm curious how that works.
Yes, a good question. And I started working on this 30 years ago, basically, when I started my research, comparing the computers that we had 30 years ago to what we have now. It's now like, wow, this is so easy now. You can literally store a lifetime's worth of conversations that a human has trivially in RAM now. It's not, I mean, hundreds of megabytes or something. As far as text goes, it just, that's trivial. You can have that totally in memory. Now, of course, visual information is much more expensive and so on. But AGI is also an excellent tool user, which is also one of the characteristics of humans that makes human intelligence so special. So it's not that the core brain, the INSA brain itself, has to have everything there. So you can offload things as well, as long as it knows where to find them and basically load them again as needed. So being a tool user and having external memories, but inherently it has photographic memory, which we don't. Whether that photographic memory is in short-term memory or in directly accessible, or whether it's just indexed, that if it needs to get to it again, it can basically replay it. So much more powerful than what we can do. But memory is not really at all a bottleneck today, which is very nice for us, because I say 30 years ago, this would have been a lot harder, We're talking with 2 megabyte computers or something, or
the floppy disks, and I mean, the 5 1/4 down to 3.5 down, zip
Right.
drives and USB drive. And now you can go to Costco and buy a 2 terabyte,
Right.
portable
Thumb drive.
SSD for less than $200. It's
Right.
like, okay, like this.
Yeah, so I don't, from how soon will we see AGI? I mean, we have a very specific roadmap where we believe we just need an additional 50 people, that we have specific work that needs to be done, like we need to upgrade our vision system specifically, and there are a number of other things that we need to do. We believe that within 18 to 24 months, with an additional 50 people, we will actually get to adult level AGI. So we believe it's very, very close. And I don't believe there's a hardware limitation at all. When you look, in fact, if anything, there's like an overhang. There's, with all the data centers that are being built. When you see what large language models can achieve already, I mean, they can do so many things at superhuman level already. The way they can summarize stuff and so on. I mean, I'm still constantly amazed using these tools every day of, I'll ask, Grok or one of the LLMs a research question, and it'll go and look at 20, 30 websites or documents and so on, and within seconds we'll come back with a summary, and then I can ask follow-up questions. It's phenomenal. And the inference part of it, of large language models, can actually run on local computers, very beefy computers, but it's really the training that requires these massive amounts of compute. So I think there's pretty good evidence that we probably already have more than enough computing power on even single devices for human level intelligence.
This is exciting.
Awesome. Yeah, super exciting. Well, Peter Voss, thank you so much for joining us
Thank
today.
you. Yeah.
Wow, this is quite a world we live in. Technology is constantly evolving. So we'd love to have you back sometime to continue the discussion. We really appreciate it.
Yeah, great. Thank you. Very good questions, and I enjoyed it.
Yeah. Well, until next week, visit our website, techtalklive.xyz. Stay tuned with the show. And again, thank you for coming on. We appreciate it.
Thank you so much.